Good afternoon, ladies and gentlemen. Welcome to TechGeek webinar series, our endeavor to impart techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. We are really sorry that there was a delay in today's webinar due to some technical glitches that Triveni was facing in logging in. Now she's back, so let us just start the session. The topic of today's session is Certificate of Cloud Computing Security Knowledge Certification, Cloud Security Fundamentals Part 1, and this is the 16th session in the Cloud Computing series. Our guest speaker today is Mr. Triveni TK, Cloud Security Specialist, Trainer, SME and a Consultant. Triveni is a freelance cloud security specialist, trainer and consultant. She holds a doctorate in management studies, an MTech and BE, and is currently pursuing PhD on cloud security. She is also a visiting professor in Manipal University and is guiding 4 projects on cloud computing. She has published award-winning research papers on cloud and cloud security. With more than 12 years of experience in teaching, consulting, and cloud corporate training for various reputed organizations, she offers well-known qualifications and is a motivator of strategies that have exceeded expectations. She is an expert on cloud security, proven cross-functional qualifications that span management, technology, and engineering. So without further delay, I introduce you all to our guest speaker. Over to you, Triveni.
Thank you, Mohini. Hi, good evening, everybody. I welcome you all to my webinar today on cloud security. This webinar is focused on Certificate of Cloud Security Knowledge, the certification by Cloud Security Alliance, which was the first organization to come up with security solutions, auditing solutions for cloud computing. A brief intro about CSA. It's a global non-profit organization with many individual members and corporate members. Its aim is to build best practices and trusted cloud ecosystem. They have an agile philosophy with applied research for cloud security. Their motto is, we want to promote the use of best practices for providing cloud security assurance within cloud computing. And they want to educate on the use of cloud computing to secure all forms of computing, including mobile computing. CCSK is the Certificate of Cloud Security Knowledge. It is a benchmark of cloud security, but it is not a replacement for other certificates like CISA, CISM, CEH, but it is a de facto benchmark of cloud security. They have an online web-based exam for the same, and the links given on this is basically for enrolling into the training or certification of cloud security. For some basic facts about cloud security, it's a timed MCQ exam. We could directly go to ccsk.cloudsecurityalliance.org and register yourself. The exam will consist of 60 MCQs, which we have to answer within 90 minutes, and the passing score is 80% of answers. If you get it right, you are a CCSK certified professional. It is not possible to stop in between, so you are advised to prepare yourselves properly so that you are not disturbed for 90 minutes and there are no technical snags. Studying for CCK examinations, the body of knowledge for the examination is already provided on the CSA portal. 92% of the questions are based on CSA guidance. It's a PDF containing all the material required to go through for the exam. It's a PDF file containing 3 different parts related to cloud security, consisting of an introduction, cloud governance, and cloud operations, 3 important sections. And 8% of the questions come from NIST report, which detail about the benefit, risk, and recommendation for info security. We can download the documents in their own website, the form of PDF. So the best way is go through these 2 documents at least 3 times. You will get a brief overview of what the material or the topics would be like. This webinar is focused on the part 1, that is cloud security fundamentals. As briefed in the TechGig portal, unless we understand the cloud architecture, it is difficult to understand the cloud security in whole. So this webinar is focused on the first part of CSA, that is cloud security fundamentals, which discuss the architectures. Part 2, which would be discussing in the next webinar series for cloud security, is focused on cloud governance, consisting of 5 different topics on enterprise risk management, legal discovery, compliance, audit, life cycle, portability, standards. Part 3 would consist of cloud operations, which concentrate on data center operations, incident response, application security, encryption, IAM, and virtualization. So part 1 agenda is limited to cloud security fundamentals. So we will first understand cloud computing to understand the cloud security. Let us start off with it. The definition of cloud computing, if you ask many people, they will be telling the truth, but they will be telling their own part of the truth. So if you ask 3 different people, they will tell 3 different definitions of cloud computing. This is from their perspective about what they are working on the cloud. An executive may tell it's a buyer-centric view of technology. A CFO, Chief Financial Officer, would see it in the terms of profits and losses. He would say it's a pay-as-you-go model. A Chief Information Officer would see it in the form of security or information, how information is stored or how the storage has changed. He would say it's basically a virtualization model. He would equate virtualization with cloud computing. Cloud computing is all of these and more. The holistic definition of cloud computing comes from NIST, National Institutes of Standards and Technology. It says that cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources. These resources could be networks, servers, storage, applications, anything. These can be rapidly provisioned and released with minimal management effort or interaction between the provider and the customer. According to NIST, the cloud computing model promotes availability. It has 5 characteristics, 3 service models, and 4 deployment models. Let us briefly see what they are. One picture speaks 1,000 words. So according to NIST, cloud computing is made up of 4 deployment models: private, community, public, and hybrid. It is made up of 3 delivery models: software as a service, platform as a service, infrastructure as a service. Cloud consists of 5 essential characteristics, and there are many giants on the shoulders of which cloud computing stands, virtualization being one of the most important ones. Let us discuss these in some detail. So basically, the same definition repeated. Cloud computing is based on enabling convenient on-demand network access to a shared pool of configurable computing resources. This particular definition of cloud computing consists of the 5 essential characteristics that has been listed in this diagram. The definition of NIST cloud computing itself has the 5 characteristics that the cloud consists of. So these 5 characteristics: on-demand, self-service. What does this mean? This essentially means that the provider will not have too much of communication with the consumer. The consumer will be able to log in online and take the service by himself with minimal communication with the provider. Broad network access. Due to cloud being accessible through internet, through network, the access will be broader compared to the traditional access. Resource pooling. Due to many users being able to log into the same service remotely, they are able to pool in, and the cost will be amortized. The cost will be spread over many users, thereby reducing the cost for the users for the same resource and also giving more profit to the provider. The more the consumers using the same service, the lesser the cost of the service. It is a win-win situation where the provider is able to get more quantity and has more profit. Rapid elasticity. Cloud computing services are basically scalable in nature, and they are rapidly scalable in nature. We are able to contract or expand as per the present moment's needs, and we do not have to overestimate or underestimate the resources needed to work on cloud. Measured service or utility computing is one of the main characteristics of cloud, wherein all the services are provided over the internet in a measured fashion, and we pay only for what we use, not more, not less. So these make up the 5 essential characteristics, and a cloud IaaS, PaaS or SaaS is inherently consisting of these 5 essential characteristics. The 3 cloud service models are software as a service, platform as a service, infra as a service. The software as a service provides applications over internet for any users who can download and use it, or they can use it over the internet itself. For example, Gmail. If you have used Gmail, then you have used cloud. If you have an ID over Facebook or LinkedIn, then you have used cloud. You have used the cloud SaaS. Platform as a service. The user is able to deploy his own application and then sell it to others, or make use of the service for himself by using a platform such as Microsoft Azure or Google App Engine or Force.com platform. Infrastructure as a service is basically the lowest part in the pyramid. They basically consist of hardware for basic computing such as storage, network capacity, computing power, computing resources, so on, so forth. The servers, storage, network, all consist of the infrastructure. So these are the 3 main services given, and most of the services could be classified into any of these kinds of services. But yes, there are many providers which give their own name for the services given by them. For example, security as a service. For example, data as a service, communication as a service. So anything could be given as a service over the cloud, but to be considered cloud service, they might have the key characteristics described in the previous slide. What is as a service? Since everything is given online, and since everything given over the cloud is rented rather than purchased, it is called as a service. This term is taken from service-oriented architecture, SOA. By rented, we are only paying for what we use, and it is on demand. Rented, on demand, and pay-per-use are interchangeably used. And there are 2 immediate advantages for such a model, because there are no upfront capital expenditure for any of these resources. And it's having a greater level of scalability compared to the traditional way in which these services could be deployed. So, as the example here suggests, if you would want to store large amount of data, we need not worry about provisioning extra servers or under provisioning them later. When we reach capacity, as and when we reach capacity, we can spend time purchasing and installing because of easy scalability. So everything as a service gives us a lot of value for money. Some examples: SaaS, we have Google Docs or Microsoft 365. If you've used any of these, Acrobat.com or Salesforce.com, which is a CRM solution, these are all SaaS models. They are internet-based applications which are hosted on the cloud, and they are offered as services. Platforms, we have Microsoft Azure, where we can develop our own applications, Google App Engine and Force.com. In infrastructure, Amazon Web Services is a global leader for public hardware, public infrastructure. Services like storage, database, compute, they are offered on demand. GoGrid, 3Tera, Rackspace, there are some other big players in IaaS domain. So, as we discussed, cloud has decoupled three important parts of any service. The infrastructure is the lower host. On the infrastructure lies the platform. On the platform lies the software. So it has decoupled infrastructure, platform, and service, and it is able to give all these three as service over the internet. Some more examples here. Now, description of SaaS. As we have already discussed, it's a complete application offered on some platform to a customer. One instance runs on the cloud, and when a user is using it, he uses one of his image, one of his machine image through the cloud. The benefits are no need of any investment, no need of software license problems, and updates are very easy. It is done in one single instance of the provider side. From the provider's perspective, the costs are lower since the provider need not go to the customer's location and install the software. So the update can be done in one location, thereby saving a lot of time for labor, transport, and other costs. Zoho, Salesforce, Microsoft, Google, many softwares are available, and industry analysts have predicted that SaaS gives the highest growth in cloud computing. What are the benefits of SaaS? Agility is the first and foremost benefit. Deployments are accelerated within minutes compared to hours or days or months in the traditional way software was deployed. It's a pay-as-you-go model. No capital expenditure, and operational expenditures are lowered by 90%. Your running costs are lowered by 90% by using the cloud. No infrastructure costs. We can receive continuous updates or upgrades from one location, since the provider will be upgrading it from his location. Because of this, there are reduced risks of failed deployments. Due to these benefits, there are increasing user adoption because of service availability through many means, through heterogeneous means. And support requirements are reduced because patches, updates, and upgrades are being handled by upstream vendors. This reduces the hassles of patching and updating. And there's a huge flexibility in deploying, which is rapidly scalable. There is no need to touch on-premise equipment. Due to this, software is very convenient on the cloud rather than outside the cloud. So Gartner survey tells that there's a lot of growth for SaaS. Platform as a service, as we've discussed, it is a layer of software or hardware that is encapsulated and offered as a service for developing a software. It is like a test bed or a development platform wherein a user can deploy his own, develop his own application for his own use or for selling it. The benefits is, if you require a hosted environment, you need not buy all the hardware or the stack required to support your development. It eliminates the need, cost, and complexity of buying and managing the hardware to develop your own application. It is an easy, simple, effective, and fast solution. Infrastructure provides basic storage and computing capabilities. As we discussed, why would anyone want to rent infrastructure rather than buy it and keep it on his own campus? The reasons are obvious. The real estate cost in today's cities, especially Bangalore, is growing day by day. So, if a provider is able to handle and maintain your infrastructure in his place, rather than you bothering about the maintenance and deploying and taking care of them, not to speak about the space required, it would save you a lot of cost, especially in heating, ventilation, and air conditioning. The buying cost is lesser than maintenance cost in infrastructure. So, infrastructure over the cloud is any day more economical, cost effective than infrastructure which is on-premise in a traditional way. Amazon, GoGrid, Tree-Terra, Joint Servers, Rackspace are big players in this domain. The benefits, as we have discussed, we want a hosted environment. Infrastructure as a service provides it. Anything can be given as a service on the cloud. As I said before, data as a service, storage as a service, security as a service, monitoring as a service. Many kinds of service are available in the cloud today. Coming to the deployment of the cloud, we have private, public, hybrid, and community clouds. Private cloud is a cloud which is owned individually by one company for its own use. Due to security reasons, an organization would not want to share the resources with other customers, so it has leased or owned its own private cloud. Private cloud can be local in-house, or a private cloud can be maintained in the provider side, but that particular server or that particular storage, that particular cloud is reserved only for one enterprise. Community cloud, they are shared infrastructure for specific community such as banking or pharmaceuticals who share one particular similar needs for security, for regulatory concerns, compliance, other needs. So all pharmaceutical companies might decide to own or to rent a cloud, and they might decide to lessen their cost by sharing it as a community, and also by making sure that their security needs, since they are similar, the security would be maintained. Public cloud. Public clouds are sold to mega scale public, so it is free for all. Amazon is a leader in this space. Since more and more users are able to use the public cloud, the cost of public cloud is the least. In all the 4 deployment models, public cloud is open to all kinds of users. At the same time, the cost of the public cloud is the least. Talking about security, inherently, since more users are sharing a public cloud, the security would be considered inherently least in public cloud as compared to private cloud. A hybrid cloud is composition of two or more of the previous three models. As we have discussed, we can see that private cloud is owned or leased by single organization. It could be within this organization's campus, or it could be in a remotely owned space of the provider, but it is always reserved for a single organization, not shared with anyone. Community cloud, several organizations, but those who have similar needs, like all banks together form a community, all pharmaceutical companies together form a community, so that their data, their resources are safe. Public cloud, used by general public. Hybrid cloud is the one where private and public are used together. The word cloud busting comes into picture when we talk about hybrid cloud. An organization which has started using private cloud to store its confidential data might find that most of its data is non-classified in nature. It is already gone out in the form of advertisements and mass mailers. So storing unimportant data, non-classified data in a private cloud would be waste of cost. So it would decide to store such data in public cloud, and it would decide to store important data, classified confidential data in private cloud. So when its private cloud is full and it is about to burst, the data would be synced to a public cloud where it is shared along with general public. So a hybrid cloud is usually consisting of a private and public cloud which are synced together in such a way that confidential information resides in the private cloud and non-confidential information resides in the public cloud. This slide speaks about little more brief descriptions of the previous four models. Cloud stands on the shoulders of the giants which led to the path where cloud is today. So it leverages all the characteristics of the technologies which were previous, such as virtualization, resilient computing, utility computing, service-oriented architecture, so on and so forth. These are the characteristics which are common to cloud computing and the previous technologies. Previous technologies had always concentrated on lowering the cost of the services given. They were also trying to scale up any technology or any resource that is given. Once more, coming to the NIST definition of framework, since we've already gone through the definition, the service models, the essential characteristics, deployment model, this picture should make it clear now. Coming to cloud security, which is the focus of this webinar for CCSK certification. Is security really a barrier to adoption of cloud or not? Yes, the answer is an obvious yes. There are many challenges with cloud computing, as we have seen in previous webinars related to cloud security. On a daily basis, there are security breaches in LinkedIn, Dropbox, and other accounts. For example, there was a Google security breach, which was a warning sign for cloud security. There have been hacks of online data sites where data and other accounts of the users have been leaked and become susceptible. Now, what is different about the cloud compared to the technologies which were before the cloud? To be clear, if we are using a provider's infrastructure, or if we are using our own infrastructure, we can make sure that our security is the best. But even if our infrastructure or platform is of best quality, is very, very secure, we can never be sure if our SaaS provider will cooperate with us to make sure that his software is safe, his software is compatible with our security concerns. Any SaaS vendor, if demanded, might not make sure that his software solution takes care of all our security and compliance needs. So, if we try our best to make sure that our infrastructure and platform are safe, the vendor's software might not be safe. Since the cloud has decoupled infrastructure, platform, and software, we have to make sure that all these three services are safe. Even if one of the layers is insecure, even if one of the layers is vulnerable, then cloud is not secure. This might be a very high level, non-detailed view, but this is truth of the moment. Whatever we might try, our provider should cooperate with our security concerns. Only then cloud security will be a win-win situation. There are 6 cloud security relevant components when we talk about cooperation between provider and consumer. These are the 6 layers created when a service is being given between a provider and a consumer. How the provider provisions the services, how data storage is done, how the infrastructure processes, how support services are given, and what about the network and perimeter security. Last but not the least, how good are the storage, processing, and virtual network? How safe are they? We'll discuss these in detail later. But before that, let us see how the SaaS PaaS and IaaS PaaS change the picture of control from the service owner to service provider. If a service provider is giving us infrastructure as a service, then the tenant or the customer has full control over the compute, application, and data part. The provider only takes control of the physical hardware. The network and storage are jointly controlled by the tenant and the provider. But if the tenant is taking the service of platform from a vendor, up till the storage part, all the hardware and the storage is controlled by the vendor. The user does not have any control over the storage or the infrastructure part. The computing and application part, they are jointly controlled. Tenant has only control over the data that is stored over the platform. If a consumer is taking software as a service from any vendor, he does not have any control over the computing part as well. He only has limited control over the application and data stored on the software. So, as the architecture progresses from infrastructure to platform to software, the control of the user is less and less and less. This is very important from a security point of view, since the customer or the tenant is more concerned about security of his data, and unless the provider who has more and more control is able to cooperate with the tenant, cloud security will not be properly provided. Other problems with the cloud are legal issues which are amplified if cloud provider data center is spread throughout the world and the cloud tenant is demanding the data center within its jurisdiction. Canada, Japan, and other jurisdictions, they do not allow their data to go out of their country, to go out of their state. So this makes cloud provisioning very difficult, since cloud by its nature is global. And if a vendor wants the data to be limited to his geographical nature, this becomes a challenge for the provider. Virtualization and risks related to virtualization. Older system was more siloed in nature. If a person wanted to hack a system, he would only hack that particular system and get details out of it. But now, one hypervisor controls thousands of systems, and a person can hack that hypervisor to hack all the systems. So rather than hacking a system, new hackers are able to hack a whole data center. This makes it more vulnerable and more dangerous. There are a list of threats given by CSA, NIST. The first one being nefarious use of cloud computing, wherein legitimate applications are being made dangerous by changing them and abusing these resources to cheat people who are regular users of legitimate applications. Insecure application programming interfaces are one more concern. If a cloud consumer is using infrastructure from some vendor, platforms from some other vendor, and different SaaS, different software from different vendors, basically making sure that these platforms and software work together, this would itself be a challenge for the user. How to make sure that different vendors and different resources and services provided by vendors fit together, that itself would be a challenge. But if these interfaces and APIs are insecure, that would defeat the whole purpose of cloud. And the most important threat for cloud computing come from insiders of an organization who are malicious in nature. 70% of hackers are insiders rather than outsiders. Shared technology issues, sharing anything with many other customers would always be a concern, since we don't know who is able to see our data in the cloud. Data loss, data leakage is the first and foremost threat as far as cloud is concerned. Account or service hijacking through cross-site scripting and other hacking is an important threat. Most of the risks are actually unknown. Our knowledge of what hackers do, how they do it, and why they do it is still unknown. Their knowledge about us is growing day by day, but our knowledge about the hackers is shrinking day by day. NIST cloud risks are listed in a similar feature. It tells isolation, failure, and data protection are most important things which we should be concerned about. ISEC threats tell authentication has been abused in a huge way by hackers, since a password is a very weak form of authentication, and many users do not know the importance of passwords or importance of passwords which are difficult in nature. People use very simple passwords and they are open to hijacking. So security is definitely a major issue apart from performance and availability, and hence Cloud Security Alliance is concentrating on educating people through its CCSK certificate. Now, cloud computing is a double-edged sword. Apart from making security a problem, cloud also makes security a solution. Let us see how. When you shift your public data to an external cloud instead of keeping it in-house, it reduces the exposure of internal sensitive data. It is like keeping your money in a bank locker. You are not keeping it in your house, but you are keeping it somewhere else where it is safe. You are keeping it with people who know how to keep your assets safe. In similar way, if you are able to trust a vendor who is good in security, and if you are able to shift your public data to some external cloud, you can rest assured that your data will be safe without any exposure. And cloud testing auditing is much simpler compared to the previous technologies because it is homogeneous in nature. It's a complex system which can be implemented in a homogeneous way. It is a well-behaved system, and hence testing and auditing is simpler. It has automated security management. It enables setting of minimum and maximum security required for any particular asset, so that the money, effort and energy that you are spending on any particular asset is directly proportional to the importance or to the particular importance of that particular asset. Redundancy and disaster recovery can be made automated in the cloud. Cloud automatically stores redundant copies of your information so that in case your data is lost, you have a copy ready with you. The challenges over the cloud is trusting a vendor, trusting that a person who is providing the service is able to keep your data safe. A customer might not be able to respond to audit findings where there were findings related to service provided through some other provider. You cannot pass the buck and say that this particular service of mine is not done by me, it is provided by some other vendor. So if we are taking service over the cloud, we have indirect administrator accountability. We cannot pass the buck. Due to loss of physical control, as demonstrated previously, cloud is always a challenge for the end user, for the customer, for the tenant. So, in the three deployment models, as we go up the ladder from infrastructure to platform to software, the provider gains more and more control and the customer loses more and more control to such an extent that when you are buying software as a service over the cloud, you do not have any control over the infrastructure or the platform, and you have very limited admin control over the applications that you are using. As we said, we will discuss about the relevant cloud components, starting with the provisioning services. The cloud provisioning is very agile. It is very immediate in nature, but due to this very nature, it is able to compromise the services given. Something which is very fast can also be very furious. So it enables availability. At the same time, it also makes sure that hackers are able to hack very, very fast. Data storage services. Basically, data is able to be stored in a fragmented way over the cloud, and it is able to make sure that the data are replicated and provision of data zones are done by country, by state, and there is encryption at rest and in transit for all the data stored over the cloud. But the challenges is the data are fragmented. How do we maintain isolation? How do we maintain multi-tenancy? How do we make sure that data is not exposed to foreign governments? Coming to cloud processing infrastructure, cloud is always able to secure the master copy, and it pushes only the secure images, secure machine images, so that whatever changes have been done, the changes will be done only to the images, not to the master copy. So the processing is very efficient, redundant, and fault tolerant. But the challenges are, in a multi-tenanted cloud infrastructure, how do we maintain all these images? How do we maintain multiple copies of the same data? And how do we process it? And cloud always relies on hypervisor. Without hypervisor and without virtualization, cloud infrastructure will not work. Cloud support services, we can have on-demand security controls by defining the minimum and maximum security required for any particular asset. We can add layers of security if any asset is very, very important. But this is a very challenging concept, since the very fact that we have added many layers of security to an asset, that would be a proof to a hacker that we are actually safeguarding an important asset, and he might want to challenge us, and he might want to make himself interested in that particular resource, in that particular data, in that particular asset. So by having multiple layers of security, we are actually showing hackers that we are hiding something important over the cloud. So this itself defeats the purpose of security. We are publishing our important assets. This gives additional risk when integrated with customer applications. You already have security controls and you have many applications. This could make it more slower unless the performance is not affected by additional security controls. Only then cloud security will work well. Network and perimeter security. We have already available with us distributed denial of service protection, VLAN capabilities, intrusion protection system, intrusion detection system, firewall, authentication. We have many layers of security already over the cloud. But the main challenge would be about mobility. We have mobile devices being used over the cloud, and according to Gartner prediction, by year 2014, 90% of organizations will allow their employees to bring their own device. BYOD, bring your own device, is a huge concept now, wherein organizations are increasingly encouraging their employees to get their own gadgets and work on corporate applications through their devices. But this gives us the challenge of virtual zoning with application mobility. How do we know what kind of applications are installed when the user goes back home with his device? How do we know how secure his device is when he works on our corporate applications? This is always a challenge. So in a gist, cloud is advantageous. It's actually good for security because whatever data is stored in the cloud, it is not stored in one piece. It is fragmented and dispersed. And there are dedicated security teams which can take care of a customer's data better than the customer himself. Cloud is fault tolerant, cloud is reliable, resilient, and redundant. And hypervisor protects against many kinds of attacks. Testing, compliance, and auditing is much simpler because of cloud. We can access on-demand security controls, and we also have advanced honeynet capabilities to attract and lock hackers and learn their behavior and find out what they are up to and how to make sure that we are not the target of hackers in future. So cloud provides all these opportunities. But at the same time, due to geographical international privacy laws, cloud providers are facing the challenge of making sure that exposure of data does not happen to foreign governments. Multi-tenancy is always a challenge. Security is always a challenge. Additional issue comes with handling compliance. There is no one compliance wherein a provider is able to give his cloud for all kinds of industries. If you want to give your cloud to financial industries, you might want to have FISMA compliance before doing so. HIPAA compliance makes sure that your cloud is good enough for healthcare industries. PCI compliance is needed before you provide your cloud to payment card industries, so on and so forth. So how do we build the trusted cloud for one particular industry? By making sure that we have a good strategy, by making sure that we educate our employees or vendors or customers, by having a good security framework and assessing that security and building for a future. This would be a cycle which will make sure that as technology improves, even our security is up to date. As far as strategy is concerned, IT architecture should support hybrid enterprise like federated IDM or service-oriented architecture. We should consider cloud as an option to any new IT initiative. We should know how will cloud create a difference in the cost, what are the features provided by cloud, and if we want to use an application, we should know if it will support different cloud deployments and will it support different providers, multiple providers. The main problem with small and medium providers, small and medium scale industries, is when they choose cloud solutions from different providers, they are not able to sync these different cloud solutions. They are not able to make them work. There are technical glitches in making different solutions of cloud work together. Risk management about sensitivity of application and data and how cloud introduces its own risk is very important consideration, and a strategy needs to be worked out on how to overcome this. Education, cloud security is a very important concept, and regularly educating employees of an organization, may it be the provider side or the consumer side, is very, very important. And CSK is doing a lot of work in this direction. It has guidance research consisting of cloud architecture as well as governance of the cloud and operating in the cloud. They give popular best practices for securing. They have come up with version 1, version 2 and version 3 cloud guidance. We could go to YKI Cloud Security Alliance.org guidance and go through all the material. CCSK is certification of cloud security knowledge. As we have discussed, it is the first and foremost security certification for cloud. They make sure that we understand the cloud issues and look for CCSKs at cloud providers, consulting partners, consumers. They have an online web-based education. The CSA reference model, like the NIST cloud model consisting of IaaS, PaaS and SaaS, as discussed in the previous slide, this is a very good reference model wherein we can understand that cloud comes with decoupling of the infrastructure platform and software, and hence unless we make sure that each of these components is safe, the cloud itself in whole will not be secure. It is a very good model to understand cloud architecture. So this was a brief about what cloud is about, and in the next 2 webinars we will try to understand the cloud governance and cloud operations part. I thank you all for taking your time out to attend this webinar. Myself, Triveni, security trainer, consultant and SME for cloud. You could mail me at this email and call me at this number for if you have any doubts related to cloud and security. I thank you all for attending this webinar. Back to you, Mohini.
Well, thanks for the presentation, Triveni. It was a wonderful one. We have a few questions from our attendees. I hope you're able to see them. You can start answering the questions now.
Yes, I'll do that. first question was by Pankaj. He asked, can you give examples of PaaS? Platform as a service. The most famous platform providers are Google App Engine. We are able to develop many applications of our own, and also we are able to test it from the designing phase through the regression testing phase. They are able to provide a platform as one-stop shop. So Google App Engine, Microsoft Azure, and Force.com are very good examples of PaaS. Ruben says, with a 12 years IT experience in US as business analyst, if I do CCSK and IBM Cloud and have the theoretical knowledge but do not have practical experience, will this make my resume saleable in the current low job market for cloud profile jobs? Well, Ruben, any certification is a proof that you know the theoretical concept, but it is not a substitute for practical knowledge gained through working directly with a provider or a customer. But yes, a certification always enhances your resume, provided you already worked in that direction. It is a proof that what you have actually done in a practical way, you also have a theoretical knowledge of that. But if your job demands a practical knowledge, you need to have a practical experience. Current low job market for cloud profile, that's not true. The word called cloud computing, if it appears in the profile, your demand will increase by 50%. I can assure you that. CCSK and IBM Cloud certification are basic certifications. They have many levels, fundamental to architect level. So it depends upon what level of certification you are passing. I hope I answered your question well. Which companies are generally recruited for cloud profiles? Well, almost all big players in IT market today are recruiting for cloud profiles. In our own India, we have Infosys and Wipro doing a lot of work on cloud security itself. Not only cloud computing, they have teams working on cloud security. So if you are interested, you could directly go to Infosys and Wipro website and search for jobs which have key terms of cloud security or cloud computing. What is Force.com? Force.com is a website. It's a sister concern of Salesforce.com. Force.com is a platform where you can develop your own application. It's a platform as a service on the cloud. Salesforce.com is a software as service over the cloud. They give CRM solutions. Another question by Pankaj. How is this whole idea of cloud computing formulated to begin with? Okay. Do you want to know who actually termed the cloud computing? Do you want to know how the term called cloud computing began? Who actually used the term cloud computing? Or do you want to know why is cloud computing called as cloud computing? Well, I assume that you are asking the second question. So the term cloud comes from older diagrams of internet where the network was represented in the form of cloud. We used to always draw between the sender and receiver of any message over the internet as a big cloud. So in between, how the message goes, which routers it is routed through, all these details we do not want to know. So we make it as a cloud. That is how the cloud computing began. Since whatever is offered over the cloud is offered through internet, we call it as cloud computing. There are many different stories about how the word called cloud was formed, or who was the first person to actually name the cloud computing as cloud computing. There are many people who actually claim to have started using cloud, Dell being one of them, but there are no specific proof that any one person started this name. So I will leave it to you to explore it further. Which cloud model has more security threats, or is it same for all? Obviously, the public cloud model has more security threats inherently because you are able to share the resources with more and more people. The security will be less and less. Private cloud has the least security threat because you are not sharing the cloud with anyone. Sahir asks, what is the benefit of CSA model of cloud? Well, the CSA model of cloud is not beneficial as such. It is a direction of how cloud services have to be. It is basically a pathway. It is a roadmap to how cloud services should be given and taken. It is not a journey where we catch your hand and lead you from source to destination. We are just showing you the way. CSA is just showing us the way of how we are able to make sure that cloud is secure in case some threats come. And if we follow the CSA model, we would make sure that the threats are less. Can you please explain why Gmail, Facebook is SaaS? Well, anything that is used over internet, that is called as SaaS. Without internet connection, you are not able to use Gmail, Facebook, LinkedIn and other social networking sites. That is the very reason we call it as software over a service. Gmail is a software that is hosted on the internet for us to use, for us to send email to each other, right? Without internet, you cannot use Gmail. So obviously it is called software as a service. It is provided in the internet. It is provided in the cloud. Can you please tell who is providing IaaS to Salesforce.com? That's an interesting question. Salesforce.com is a customer of Amazon Web Service. Salesforce provides a software, but its own infrastructure Amazon Web Service provides. So that is the question of your answer. How much time do you think it requires to be comfortable in cloud computing if one do not have any prior experience of cloud but are into web development for last few years? Nitin Sharma asked this. Well, you could learn cloud computing in 1 hour, 1 day, 1 week, or you could go on for years and still be thinking that you don't have a full picture of cloud. So the more you read, the more you feel you don't know about this particular technology. It's as simple as that. Since you're already into web development, I think you know how it works. So it will be easy for you comparatively to get yourself up to speed in cloud computing. Sahir asks, want to go for PhD in cloud security, how to move forward? Well, all universities are offering PhDs, but they are not giving cloud security as a PhD topic. You could go to Indian Institute of Science, any IITs. Many institutes abroad offer PhD in cloud computing. So you could choose security as a subject there and do PhD over there. Shahir asks, can you brief in how disaster recovery as a service is matured in the current market? What are the companies in India which offer this service? Well, most of the companies which have disaster recovery have their own in-house team to monitor their own resources. So usually disaster recovery is not outsourced much. As far as maturity of disaster recovery in current market is concerned, as and when the technologies have matured, even the disaster recovery is also going in great strides. Almost all the IT companies have their own disaster recovery team. There is no one IT company in India or abroad which doesn't have a disaster recovery team. Anjana asks, is it IBM that introduced cloud computing? Any older version that is similar to cloud computing? Well, yes, IBM is considered as one of the trailblazers along with Amazon.com. Amazon.com started this whole story of going into cloud by having what is called as their Amazon Web Services. But yes, IBM had virtualized its servers back in 1976 itself. In that way, they are leaders of cloud computing. So I cannot tell you that IBM introduced the term, but yes, the term called cloud computing was being used much before 1990s in many small companies. But the cloud computing term itself, how it came, we don't know. The technology as such, IBM is one of the trailblazers. IBM is one of the leaders in it. As a beginning, which certification should be done for cloud? Is there a defined path if one wants to build expertise in cloud computing? Yogesh asked that. Yes, I would definitely suggest you go through all the free materials on cloud first before taking any certification. I myself train on Exin, CompTIA and Cloud School certification. I'm a Cloud School trainer as well as a content developer. You could mail me to get further details on it. You would want to attend cloud certification, I would be happy to help you guide on this path. Jayavarapu asked, what is the impact while migrating applications from box server to cloud? Well, most of the applications which are legacy in nature, they always have a problem migrating to the cloud. Some applications might never work on the cloud. Some applications might never be fit for the cloud. So it will be an incremental approach. It is not a big bang theory wherein whatever you have in your institute, just one day you decide to jump over the cloud and jump it. It doesn't work that way. It will be an incremental approach where you try one by one application and see, does it fit, does it not fit, so on. Rajesh asks, what is the requirement of virtualization platforms in implementing cloud? Well, as I told you, without virtualization, cloud will not work. Without hypervisor, cloud doesn't work. So virtualization is a prerequisite for the cloud. Rahul asked, how much time do you think cloud computing would take over traditional IT infrastructure? It has already taken over. Yogesh asked, how is VM certification different from any other cloud certification? VMware certification, and why VMware cloud certifications have so many layers and are much costly? Well, any industry related certification is definitely costly because it is vendor specific. VMware certification is specific to all VMware products, hence it is costly, and if you get their certification, you will be able to get jobs in their domain. Compared to Exin or CompTIA, VMware certifications are definitely more costly. I agree on that. But your niche area would also be very strong in that way. Instead of being a general cloud computing certified professional, you would be a VMware certified professional. That would increase your job opportunities where VMware professionals are needed. Unfortunately, there are many certifications and people are spoiled for choice. They don't know where to go, where to start with, and what to take next. That is always a challenge. Shahir asked, what are career opportunities for MBA candidates in the field of cloud computing? Well, cloud computing is actually a business strategy rather than a pure technology. It has two sides. It is like two sides of the same coin. One part of cloud computing can be business side, where you might be able to help new companies who want to go to the cloud or who want to provide cloud as a service in sales and in business. So there are huge opportunities for MBA candidates. Since you already have done business administration, going into the business aspect of cloud would be more attractive to you. There are huge opportunities here when you see cloud computing as a strategy. Niaz Ali says, what about certification of Amazon Web Service? Is there any certification that is more helpful than AWS in infrastructure domain? You will not believe me, every company which is providing IaaS, PaaS or SaaS, Salesforce has its own certification, Amazon has its own certification, Microsoft has its own certification, IBM has its own certification too. Now it is left to you. Do you want to become an Amazon certified professional where you want to work with customers of Amazon? That is left to you. It depends upon what job opportunities you are looking at. I cannot tell you that some other certification is more helpful than Amazon Web certification. I would always advise you to go to a vendor neutral certification first, such as Exin certification or CompTIA certification or Cloud School certification. That way you will be vendor neutral and all providers irrespective of whether they are Amazon or Microsoft or Salesforce, they will be able to hire you because you have a basic foundational certification. The most in-demand certification, believe me or not, is the foundational level of cloud rather than vendor-specific advanced certification. So you start off with any of these fundamental certification, then you see where you want to go. How to go for Citrix certification, what are its prerequisites? As far as basic Citrix certification is concerned, there are no prerequisites. You need to know only the basics of network and how to work with internet. That's more than enough. I guess these are the questions. If any more questions are there, please mail me or call me. I'd be happy to answer your questions. Back to you, Mohini.
Well, thank you so much for the presentation, Triveni. It was a great one. I'm sure all our attendees got answers to their questions. Well, I would also like to thank our attendees for making this presentation a success. The recording of this session would be available on techgeek.com by tomorrow. Thank you all. Have a great evening.